So I'm Peter Bojanic. I'm the director of the Lustre Group at Sun. I know many folks in the room from my CFS days. I came from Cluster File Systems. We were acquired over a year ago on October 1st, 2007 by Sun Microsystems. But we'd worked together for years before that doing deployments at TAC, as Mark Hamilton was talking about, at TAC and KISTI and so forth. So a lot of the most successful Sun HPC storage deployments were done in very close partnership. And we liked each other so much that we got married. So I'm here today to talk about Lustre and where we're going. So on the latest list, you will find 70% of the top 10. So 7 of the top 10 supercomputers in the world running Lustre. We were 7 this time last year, then we went down to 6 at International Supercomputing at that updated top 500 list, and we're back up to 7 of the top 10. More than 40%. Last year we were 40% of the top 100. This year we're a little bit more than that, so a little bit more than 40% of the top 100 systems run Lustre, and 75% of the top 200 systems in that top 500 list are all running Lustre. So Lustre scales to the very largest systems in the entire world, but also runs on some of the more moderate of those supercomputers in the top 500 list. So I'm going to talk to you today about some Lustre roadmap highlights. I'm going to introduce Snowbird, which is an exciting new innovation, and talk a little bit about Lustre and ZFS. So hopefully I will answer some of the questions that you might have. We'll take some Q&A later on. So for those of you who don't know Lustre, I'll just recap that it's the world's fastest and most scalable storage solution. It's a parallel, scalable POSIX-based file system that aggregates petabytes of storage, so multiple petabytes of storage, all in one unified namespace. Supporting tens of thousands of clients. I think our biggest deployment to date is like 25,000 clients or something like that. So tens of thousands of clients, hundreds of storage servers, high performance heterogeneous networking. We run on GigE, we run on InfiniBand, and we run on a number of what were previously a little bit more esoteric high performance interconnects. So we were the first file system to run natively on Elan, natively on Marinette and so forth, and we were, I think, one of the first clustered file systems to run natively on InfiniBand. We also work with iWarp and those innovations. High availability, so failover, so your file system can stay up even if individual components fail. The software is open source. It's licensed under the GPL, available under Linux today. It's multi-platform, so it runs on not only Sun's hardware, but a lot of other OEM vendors, and you can get it from multiple vendors. This is actually one of the most important things about Lustre, is that it's becoming a de facto standard in HPC. We believe that Sun is the best place to come for your Lustre-based storage solutions, but almost all of the large HPC vendors in the world are deploying Lustre solutions today. And in that top 500 list, you'll see a really good representation of both really impressive new Sun HPC systems, as well as some other systems by some of our OEM partners. And it's a modern object-based architecture. So this is what a Lustre cluster looks like. You've got scalable object server nodes. So you add object storage servers in order to scale your file system size and the aggregate performance. Metadata server. Oh, thank you. Hey, great. Yeah, so your object storage servers allow you to scale. That can be connected to either enterprise class storage arrays, or it can be connected to lower cost commodity storage, the Sun JBODs, the Riverwalk and the Alamo and so forth is the way that we're currently deploying these solutions at Sun. Currently one active metadata server with a second one for high availability standby. And with clustered metadata in the next year, we'll see that you'll be able to actually scale your metadata performance the same way that we scale object storage servers today. So you'll be able to scale up to hundreds of metadata servers. Easily tens of thousands, going to hundreds and thousands of Lustre clients and beyond, running on a number of different fabrics, including networking in the Lustre stack that it is able to do, take advantage of RDMA capabilities in the fabric. So that's a Lustre cluster in a nutshell. Here's kind of the current Hall of Fame, and Mark, you'll definitely want to grab this latest version because there's a couple of interesting updates here. Livermore Blue Gene was for some time the #1 supercomputer in the world and dominated that top 500 list for a period of time. Lustre runs on Blue Gene L. They're up to 3.5 petabytes of storage on that system, achieving 52 gigabytes per second That's, yes, gigabytes per second. And regularly running with over 200,000 client processes connected to those file systems. TAC Ranger, more than a petabyte and a half of storage, 40 gigabytes per second of I/O, running on almost 63,000 processor cores. Sandia Red Storm, probably our highest client count. I think that's almost 25,000 clients, but 12,960 multi-core computer sockets, 340 terabytes. That's not a very big one, but 50 gigabytes per second was pretty good for a period of time. We're pretty sure that that the Jaguar system at Oak Ridge, and we've been working with this system for a couple of years, but it's just going through a major upgrade now. We expect that file system, when it's in production, to be 10.5 petabytes of storage and 240 gigabytes per second of I/O. That will set a new world record for Lustre I/O. And so I had already told you about Lustre in the top 500. One of the most exciting things that you'll see in Lustre in the coming months is actually the world's first feature-length animated film rendered on a Lustre cluster. So Framestore CFC in the UK have been using Lustre for a number of years. They've done all the special effects for the Spider-Man movies. They've done the Harry Potter movies. They most recently did the Batman, the Dark Knight film, Harvey Dent, Two-Face. All of that was rendered, all those special effects were rendered on a Lustre cluster. And now Framestore have actually done their first feature-length film. It's called the Tales of Despero. You can go, you can find this easily on the website. There's trailers and so forth. Some interesting statistics here. It was rendered on a 200 terabyte Lustre file system, so kind of a small file system actually by Lustre standards, but respectable. An average of 1,200 megabytes per second of sustained reads per day, peaking at 3,000 megabytes per second, so 3 gigabytes per second, 5 terabytes of data generated per night, and 4,000 processor cores per night. So not necessarily one of our most high-end systems, but probably one of the more exciting ones. This is where we're going. So all of that was achieved with the current shipping version of Lustre, Lustre 1.6. This is the roadmap for the next year and a bit. We're announcing Lustre 1.8 at the show today. This is a maintenance upgrade, but we really think that a lot of users are going to want to go here because it introduces object storage pools, which is a way to start to carve up storage into heterogeneous chunks. So you could have fast flash storage separated off as a pool, differentiated from your spindle. So you could, for example, have a /Lustre/fast directory that maps that directory to a number of SSD devices. Object storage pools also layers the foundation for a lot of our new innovations that are going to be coming, like HSM support and a lot of other capabilities for migration. So OST pools is in itself a valuable feature, but lays the foundation for a lot of really exciting features to come. We will be introducing a read cache, so this is not a hardware-assisted read cache like the ReadZilla in Amber Road, but rather a software-based OSS read cache. So we will be able to accelerate a lot of the read operations, especially for codes that have multiple clients that have to read the same data and then do some processing on it. We'll see perhaps many times performance improvement for certain types of use cases. A number of recovery improvements. Lustre recovery works very reliably at like 1,000 nodes or something like that. But once you get to up to 4,000 nodes, certainly when you get to 10,000 nodes, that recovery model was starting to not perform very well. So we've got a number of recovery improvements to improve our high availability support. Improved SMP scalability, so clients that have multiple processors, multiple cores, we're going to be exploiting those a bit better, and interoperability. This lays the groundwork for interoperability with Lustre 2.0, and that will be, that's available today for download from our website in beta code. We'll be shipping that for general availability next month. Lustre 2.0 kind of is the next generation of Lustre that introduces a lot of new code innovations and will pave the road for some significant features in the future. Replication, clustered metadata early access, security early evaluation, all of these things will be delivered in Lustre 2.0 next spring. April timeframe is when we're looking at for general availability. And then incremental maintenance releases will continue to layer in performance and scalability enhancements. The Lustre Group is constantly, sometimes they're big, sometimes they're small, but we're constantly layering in all kinds of performance and scalability enhancements as we deal with bigger and bigger systems. And we will also deliver ZFS early evaluation. So this is Lustre running on the DMU, the data management unit. Initially, again, this will be on Linux as we make our trajectory towards delivery on Solaris, and we'll deliver that security in a production mode. So this will enable secure and encrypted, secure authentication and encrypted traffic over wide area network links, which is one of the reasons why it's so important to a number of our customers who are running Lustre successfully over a wide area. Lustre 3.0 next year will bring about the clustered metadata, so I told you about that. That's the scalable metadata capabilities. We will also introduce ZFS as an alternate file system to LDiskFS. I'll talk about that in a moment. For more performance improvements with the right cache, network scalability improvements, HSM integration, initially with HPSS, because that's what a number of our development partners are helping us with, but we will be looking at additional HSMs from Sun and from other vendors even, online data migration, and native Windows client. So tall order for next year. A lot of those technologies are already under active development. A couple of other things that I'll just highlight. Again, advancing how we work with and how Lustre performs at scale over its object storage servers will introduce a kind of an innovation that introduces disk elevator capabilities at the network layer, so the network request scheduler. PNFS exports, native Windows client, and platform portability enhancements to enable us to get to other types of client platforms like Solaris and Windows. And then a lot of active research, although we don't know exactly when it's going to go into a release, exploitation of Flash, IPv6, and so forth, and Solaris client and server. We don't want to tell you when it's going to be available yet because we're still kind of working through some of the details. But a lot of the engineering work is well underway. Lustre scaling today, clients in the range of like 25,000. By the time we get to Lustre 3.0, we expect to be supporting hundreds of thousands of clients. And then through proxy clustering and other innovations, it's actually our goal within the next 5 years to hit 1 million. So 1 million clients in the next 5 years is kind of the target that our most demanding customers are asking for from us. Object storage servers today in the thousands. By Lustre 3.0, probably close to about 2,000, and then another 1,000 within about 5 years. And the metadata server, we've been peaking at one active plus one passive standby. Lustre 3.0 will introduce support for up to 32 metadata servers, and then beyond that, up to 100 and more within the next 5 years. So scalability, it's all about scalability and performance for us. That's kind of our primary mission. Lustre in the future, continuing to focus on extreme HPC, but scaling to exabytes of storage. Trillions of files, multiple terabytes per second of I/O, and hundreds of thousands of metadata operations per second. And these aren't just hopeful wishes. We truly know how we're going to get here. And there are customers like DARPA who are expecting us to get there for some of their future requirements. So that's Lustre, and those of you who work with Lustre know that in some cases it's not necessarily, we're not renowned for the easiest product to set up. And so we're going to be introducing Snowbird, which is a Lustre-based storage product. I'm not going to use the word appliance because it's not really an appliance in the same way that Amber Road is. But it is an innovation that will make Lustre easier, more accessible and simplified for a broader variety of HPC customers. So it's the fast storage cluster entry point, a number of predefined configurations that are based on Lustre and leverage open storage products like our JBODs and servers and so forth, and Flash in the future. It integrates the software and the hardware and the services to simplify deployment to simplify delivery to the customer and also deployment. So the idea is that these Snowbird appliances will show up at your site, and then the only thing that you need to do is configure the networking, aggregate the storage into a file system, and that's it. No installing of the operating system, no installing of Lustre, no applying our kernel patches, no worrying about configuring the RAID arrays. All of those choices are made in advance. So it simplifies for our salespeople and for our partners. It simplifies the quoting, one part instead of a bunch of different parts, and it simplifies the experience for selling for Sun and for our partners. We're not taking anything away. Custom Lustre configurations are still available. So if the Snowbird options don't meet your needs, then we can still configure out of a lot of the open storage components that we have, custom Lustre configurations that meet your needs, and there's currently support available for those today. So these are the Snowbird building blocks. We'll have a high availability MDS. So this is one MDS unit that will be able to that will be high availability. We'll have a corresponding high availability building block for the object storage server. So this is a failover kind of server. And then for users for which high availability is less important, but you're looking for a much more attractive price to storage, there's a basic OSS which is based on the Thor storage. So no high availability, but high density of storage. So we're pretty excited about that. This is all the software is integrated. So not only the Lustre, but also the RAID optimizations that we put into Linux, Open Fabric stack, the IP stack, and the heartbeat and the monitoring tools that you need for high availability. Traditionally, we've left these up to our customers or to our integrators, our OEM partners to integrate, and now Sun is delivering an integrated solution for Lustre. So it enables extreme scaling. It accelerates the time to results, so you can get Lustre-based solutions up faster and more effectively. We can rely on consistent results, so standard configurations that simplify the deployment, and high availability options are pre-configured. And then breakthrough economics. We're expecting that this will be 50% more cost-effective than traditional storage architectures for Lustre deployment. Lustre and ZFS to round out this discussion where we're going. So we've been talking about Lustre for a long time. We're introducing Snowbird, which is an integration of software and hardware and services. We've talked about Victor talked about Amber Road and Fishworks. You can probably guess where we're trying to go in the next couple of years. It's not that it probably doesn't take too much to speculate, but we have to go through ZFS first, and we have to get to Solaris. So why do we want to support ZFS? Well, you probably have a number of your own reasons. We've been talking for a couple of years about the benefits of ZFS. End-to-end data integrity is effectively the most compelling part of the story that I want to tell you about. So lots of benefits to ZFS, but what ZFS we already know offers superior and differentiated data integrity through RAID-Z and checksumming and copy-on-write transactional design. I won't delve into all those details. Lustre has its own end-to-end data, its own data integrity features. So the Lustre protocol between clients and servers checksum data when it leaves the client memory. Before the RDMA over the network, and then when it arrives at the server, after the RDMA, the checksum is checked. We introduced this in Lustre 1.6 because at one of our biggest installations, at one of our biggest HPC installations, we were trying to diagnose for many weeks, a year or so ago, inexplicable data corruptions. And initially we thought perhaps this is a defect in Lustre. We thought perhaps it's some defect in the disk controllers that wasn't being reported up. After considerable research and investigation, including instrumenting Lustre with checksumming capabilities, we determined that it was a number of internet cards that were silently corrupting data from the client to the server. So what started off as a diagnostic tool became a fairly important feature for Lustre's data integrity model. And so when we put ZFS together with Lustre, what we've got is probably what we believe to be a unique solution in the world for end-to-end data integrity. And so that the data that's sitting in your client's memory, when it leaves the client's memory and transmits over the network and is persisted on storage, we can be we have a high degree of certainty that data is going to arrive and be persisted correctly. So end-to-end data integrity. Victor mentioned horizontal versus vertical scaling. what ZFS offers, ZFS allows us to break a limitation that we have with ext3 on Linux today. It allows us to scale to zettabytes of storage on a local file system. Today we're limited to 8 terabytes in a single run on Linux. We're hopeful to be able to get like to 12 or 16. Nowhere near where we need to be for the most high demanding HPC applications. So zettabytes of storage in a single server. The hybrid storage model offers, in excess of 5 times the types of improvements that you would get from just plain disk. InfiniBand and open source solutions based on ZFS. So ZFS allows you to scale really effectively in a single storage server, and that what Lustre enables is horizontal scaling. So you put a whole bunch of those together and you aggregate the performance with horizontal scaling. So we have the file system size and I/O throughput increases by aggregating additional servers. We have the Lustre protocol. That's both high performance, high efficiency for bulk transfers, and also offers that data integrity checking over the network. Supports file systems with up to hundreds of servers and tens of thousands of clients. So on Linux, what we'll be doing, just as ZFS uses, there's ZFS, there's the ZFS layer that makes the technology of file system, but really the heart and soul of ZFS is the data management unit. So when we talk about Lustre support for ZFS, we're not actually talking about taking ZFS, putting it on Linux, and then running on top of that as an underlying file system. We're actually talking about using the transactional engine that the ZFS file system on Solaris does. It's the data management unit. And so we will use the data management unit on Linux in very much the same way. And so we'll just talk to the DMU as a block device as we do today. The DMU provides APIs for doing transactions. We will write ZFS format to disk because, as we learned with Lustre, it's extremely valuable for development and for diagnostic purposes to be able to mount that underlying file system on your object storage server and actually look through it and sift through the data if you need to. And so we'll format with ZFS so that you can still do that same kind of mounting for development and diagnostic purposes. And the DMU is highly portable. It's already running on OS 10. We've got it running on Linux already. And in the new year, we'll be packaging that up with Lustre 2.x for early evaluation. So just to round this out, Lustre enables the biggest HPC deployments in the world today. We're going to be taking that success that we've had with Lustre and simplifying it into Snowbird configurations that deliver integrated Lustre-based solutions that are highly scalable yet easy to deploy. And then ZFS and Lustre will work together to offer a powerful combination of vertical scaling with horizontal scaling and unparalleled data integrity protection. So we're pretty excited about the next year, and even more excited to be working with other engineering groups and product groups inside of Sun to do some truly innovative things with Lustre and Fishworks. So maybe I'll have some exciting stories to tell you about next year.
Thank you so much, Peter. I'm sure there are questions for Peter. I mean, Lustre is too important in our strategy. There's one question. Torben? Yeah.
Thank you. It was an interesting roadmap. But you talked about in version 3 combining ZFS and HSM. Do you have any information what will happen to SAM QFS?
So I don't have a lot of information. I would say we work very successfully. So Lustre and SAM QFS are integrated very successfully today in some of our largest deployments, like TAC. Texas, we're going to go see TAC tomorrow. So SAM QFS is deployed there as the archive solution. So Lustre is the high performance file system for doing work, for doing compute work, and for persisting the data. And then for archival purposes, that's sent off through a data mover to SAM QFS. That's a fairly naive data mover. It's kind of like just doing Lustre doesn't really know anything about SAM-QFS, and SAM-QFS doesn't really know anything about Lustre. What we're working on with CEA, the Atomic Energy Company in France, is integration, is as a model for HSM integration into Lustre. So this will create a more intimate connection between the HSM and Lustre in a very modular way, so that you'll be able to adapt Lustre through plugins to work with a number of different HSMs. The first one that we're working on is HPSS, and that's largely driven by the customers who need this the most, who are all using HPSS, and CEA, who are a development partner, a community development partner. So HPSS will kind of be the first one. We're working with the SAM-QFS team to determine kind of how we can achieve the same kind of thing with SAM-QFS, eventually with our future archiving system. And then we're also talking with SGI. SGI are contemplating writing their own plugin for Lustre so that they'll be able to have DMF work with the HSM solution. So some of it is our development work, some of it will be done by the community. But again, Lustre is an open source product, so it's expected to see a lot of kind of innovation.
Hi.
Kevin.
Peter, we hear a lot about file systems such as Hadoop in the context of cloud computing. Can you talk about Lustre and cloud computing a little bit?
Sure. So we're embarking a little bit on how we deliver the value of Lustre into. So the question was about Lustre and cloud computing, and Hadoop was used as a reference. Lustre to date has been, so Lustre is highly scalable and it works effectively over a WAN, and we're going to make it even more secure over a WAN. So those types of capabilities will help us transition into cloud computing type configurations. We're actually working on with a number of interns on a small research project to introduce a Hadoop interface to Lustre. So Lustre has traditionally been entirely POSIX. POSIX semantics. But for some of the most demanding HPC applications, they don't necessarily care about POSIX semantics. It's useful to have that large aggregated unified namespace, but you want a different kind of API, perhaps a more performant API, because you don't care about the POSIX semantics. And so Hadoop becomes, we'll introduce a Hadoop type API to Lustre, ideally exactly the Hadoop API, so that you could, understanding that you're relaxing POSIX semantics when you use that API, still take advantage of Lustre's high performance and scalability. And then we'll be looking for other innovations. So if you have any ideas of how to apply Lustre in cloud computing, I'm very interested to talk to you today.
One question at the back.
Hi, Peter. I got a question for you.
Hey, Kevin.
Actually, there was a couple comments in the back room. Would you mind just elaborating a little bit more about Snowbird? Snowbird as its value proposition in being an easy-to-use solution that gets into a sort of a broader market than just the typical high-end that Lustre's always been present in. And I think it would be really valuable to hear some of the value that Snowbird's bringing to that broader market.
So one of my mentors when I was very early in my career used to say when I was programming on VAX VMS systems, he said, if it was hard to write, it should be hard to use. And we don't actually, and that's traditionally kind of been what Lustre was. It was really hard to write, and it was traditionally fairly hard to use. Anyone who's been with us since the Lustre 1.4 days would know that the configuration model was, it required a master's level education in order to be able to configure Lustre. We simplified that dramatically with Lustre 1.6. But still, if you wanted to deploy a Lustre type solution, you have to integrate the hardware. There's a whole bunch of software to get together in the stack. I think I saw the original installation instructions from TiTech that Ihara and others did, and it was like pages and pages and pages long. So we're going to reduce that down to a couple pages. We're going to dramatically simplify the entire process for getting Lustre installed and configured. And so in that respect, we'll be deploying a simplified configuration, but more importantly, I think even more importantly than being simple to deploy, it's understandable. We know exactly what the configuration is going to be. So if there is a problem, we don't have to start off with, well, what are you running and what kernel are you running and what kind of storage and what's your server and so forth. We'll know exactly what the environment is. And for any of you guys who are supporting software or working, there's a tremendous benefit that you get from sameness, right? Things being the same. And so what we're introducing from a support and a deployment model is a high degree of sameness, so that we have something that's deterministic and we know how to deploy it and we know how to support it effectively.
Thank you very much, Peter.
Thank you, Philip.